Okay. So we're recording to the Zoom cloud, so that yeah, so that so that when the session is going, they are recording it on the server, so that we don't have to worry about stuff. So the first contest you will have, there are 4 contests, right? When you join ACSL elementary division. So there are 4 contests, and I should probably just do this.
Number systems, contest 2, elementary prefix, infix, postfix, notation, contest 3, contest 3, elementary Boolean algebra, contest
And
4,
3.
elementary graph.
Yeah. And then there's the final, right? And if you get scored, if you get high enough scores, you go to the final.
Can we do it?
I believe you can actually.
Wait, how come there's like 2020 to 2016 in like each contest?
These are previous years contests. Sorry, what? Yeah, when you join the contest, right? When you enroll in the contest. Say that again. 8 tests or 8 tests. No, it goes like this, right? You have because there are so many teams in these contests, right? So when they have these tests ready, they will put it on this site called HackerRank. So you go on to we will organize that, right? When you guys join as a team, then we organize that. So as a team, we'll have to get on there together. And with each one of these contests, right, 1, 2, 3, 4, you have basically 30 minutes to finish like 5 questions, I believe. So let's say if we do this, last time we haven't finished. I think last time we worked on this one, right?
Yeah.
So we haven't quite done with this one yet. So we're gonna finish this today.
Oh my God, that's so much.
And so you can see that this is a contest, right? So you have 5 questions, right? And you have 30 minutes to finish this, right? So each time, the format is pretty much the same. This is contest 4, right? So you have 5 questions about graph theory. And that's all you have for this session. Okay, and after you finish on number 4, then they will, score, get you guys scores, and then determine if you go to the final or not. All right, and when you go to, for example, junior level, when you guys go to middle school, you go to junior level, then you have these contests. Each contest will have 2 different topics, 2 different subjects, right? And then, but the format is similar. And then you also have a programming problem, right? With the programming, you have 72 hours, 3 days to complete that. Okay, finish that and submit the solution. So these are the formats, right? And so we have gone through all these 4 different subjects, right? So if I refresh this, so contest 1 is elementary number system, and 2 is expression, right? Postfix, infix, prefix, and then Boolean algebra, and then graph theory, right? These 4 subjects. And then in the finals, you can see that it's probably a mix of different things, right? So when you get to that, you're gonna, they're gonna give you problems for basically all the subjects that we have talked about, right? In this altogether. So any question about that? It's straightforward enough, right?
Okay, can we do it?
Pardon me?
Can we do it?
Yeah. And what we will do is you go back and, assuming that you're interested, talk to your parents, and then your parents talk to other parents. Then we form a team and go register, and then we participate. And these things will come out at the end of October. So every week you'll have a contest. It goes for 4 weeks, right? And then there's the final. I don't know exact schedule, but it's going to be after the 4 weeks, right? And then I think that's pretty much it, right? I think we have gone through all these subjects without a whole lot of issues or problems, right? So I think to get higher scores, you just need to really practice. I don't know if there's any other way to do that. So this is what we did last time. Right? Last time we were at problem 3, right? And we didn't finish that. Did we finish? Did we complete 3? Okay. If we go on to 4, 4 is this, right? So in question problem number 4, you have this graph with A, B, C, D, E, 5 nodes.
I think it's like, no, I think this one's like the question 3, but like with different columns.
How many cycles are there? Right? So what we do is we basically just use the order of the letter. We start with A, right? A, B, C. We can't get to D. So A, B, C, D, A. Right, that's 1.
Oh, so cycle.
Okay. Cycle. So let's open a notepad here. Give me a sec. I'll open up a notepad. Notepad probably doesn't. Notepad probably doesn't open up a WordPad. So that we can make the letters bigger. All right. A, B. All right, that works.
Which is AECB count.
Yeah, let's use the order to our advantage, right? So we can, so we did A, B, C, E, A, right? That's a cycle.
A and then AECB.
Um,
wait,
right.
No, AECB.
Well, let's try using the order. So we can do A, D, E, A, right? That's one. That's another cycle. And the next one is A, E, D, A, right? A, E, D, A, right?
Yeah.
So we try to use the order of the letter to do this. So A, B, C, E, D, A, right? And then we have A, D, A. We have done E, D, A already.
AED. It's going a different path. Because look.
Yeah.
Okay, so it's going over here. That's ADEA.
Right.
But then if it's AEDA, it's just it's like the same, but
Right,
it's
right.
not.
We have both, right? We have A, D, E, A, and
Oh,
D, E, A. So and then we also have A, E, C, B, A, right?
What about ABC?
Oh, sorry.
AW. We got a W for a win. Let's go. AD.
And before that, I guess we should try A, D, E, C, B, A, right? Do we have more?
Well, we don't think so. Are you allowed to start on?
No, that's exactly right. Yeah. But when you start with E, it's the same cycle, right? If you are doing like E, A, B, C, E, then it's the same as A, B, C, E, A, right?
Melody, how much did you get?
So we should
No, she's
do this. So A, B, C, E, A, A, B, C, E, D, A, right? So A, D, E, A, A, D, E, C, B, A. Because every single one of these has included E already, right? So if we start with E, we're gonna repeat, right? But there are a few that does not include D, right? This one, A, E, C, D, A. This one does not include D, and this one does not include D, right? These two does not include D, right? So if we start with D, we might have,
You do D, E, C, B, A, B.
so if we, let's try D, A,
Wait, but
B,
like, what?
C, E, D, right?
Wait, what are the answers again? 4, 6, 8.
How did it become so small? Let's try to concentrate. Okay, so D, A, B, C, E, D, right? Um, let's see, A, B, C, E, D, A.
Wait, what if we started at B?
Yeah, you're right.
B is it? B is just-
So we scrap that. Is there another one? D, E,
There is D, E, C. Wait, D, E, C, B. Wait, no. There's D, A, no, D, E, A, B.
yeah, I guess that's pretty much it. Is D, A, D, E. There's another one which would be this, right? D, E,
D, E, C.
D,
No, I don't think
D, A, D, right?
D, A, D. Dead. Dead.
But that's the same as AEDA, right? ADEA, right? Also, I guess here is DAED, right? So that we are repeating there. So it seems that we just have those 6. Is that correct? Let's see.
Wait, y'all check. Wait, Melody,
So-
can you see this?
We do have the solution, which is,
Melody, can you see this?
so let's see what else are there.
It's E.
Yeah, it is 6. Okay, so
Don't show the other answer. No. It's not about the answer. It's about understanding
Yep.
and other stuff. Also, that's what my
Okay. So that's it.
Okay, so we know it's A, but like it's a, identify the starting and ending vertices that can be used for the following graph to be traversable.
Remember that what makes it traversable.
I don't know. I forgot what traversable is.
Right, but there's a condition for a graph to be traversable. Remember that?
I forgot. You have to.
Melody, do you remember that?
Huh?
Yes.
I don't remember.
Okay. It has to do with the number of what is it? Degrees. What is the number of degrees on a node, on a vertex? Exactly what I'm asking you, right? So the number of degrees, for example, on E is, it has two in and out connections, right? So the degree on E is 2, right? And on, what's on D?
Wait, so is that like,
Four.
how many pathways?
Does it mean it's the equal number of degrees? Be traversal?
For this to be traversable,
Wait, so, by traversable, I mean, no, 4 degrees, you mean like how many pathways are? So, okay.
what is traversable? No, it actually means to go, to walk across every single edge. One time,
Oh,
right?
wait, so we have to make this traversable and it's not traversable right now?
Right. What makes it, what makes it traversable, right? Is it traversable?
No, it is not.
Can you go from starting at one point and then go over every edge exactly one time?
But then like, but it, no, you
You
gotta,
can, but it depends on your starting
okay, no, hold on.
point. Well, if you start at E, or
Okay.
F,
Okay, so,
Well, first thing is that it has to be connected, right? The graph has to be connected, for sure, right? If it's disconnected, then obviously, because you can't walk across. So it is connected. And then the second thing is that the number of nodes with the odd number of degrees has to be,
even,
you don't remember?
not a,
It has to be 0 or less than 2, right? Either 0 or 2.
how many degrees there are?
Meaning that the number of nodes that has odd number of degrees, right? Like this one, G has a degree of 3, right? And what else? J, right? Has a,
They're both odd.
has a degree of 3, right? These are odd numbers, right? So for this to be traversable, you can only have 2 of such nodes or not. Does that make sense?
2 of such nodes, but then how do we get
2
rid-
nodes that have odd number of degrees. The nodes with odd number of degrees. How many do you have in here?
yeah. Right now.
G and J.
Okay.
So you have 2 in here. That makes traversable, right?
So if you have 2 nodes that have an odd, no, 2 nodes that have an odd number of degrees, then it's traversable?
2 or not. If you have only 2, that's okay. If you don't have any, that's also,
Starting and ending
Exactly.
braces that can be used for falling.
if you have 1,
Wait, but then why is
actually
the,
you probably can't have 1, but if you have more than 1, more than 2 nodes that has odd number of degrees, odd number of connections, then it's not traversable.
what about
That's
D?
the,
no, D is 4.
right? If you just mark it, this is 2, right? This is 4, this is 3, this is 2,
Yeah, that's 2.
3, 2, 2, right? Just write it down, and then you can just count it, how many you have that's
Odd.
that's odd number, right?
Yeah, so then that's 2.
In here you have 2, so it would be fine. It
So
would be traversable.
So that's how you get GJ. That's how you get A. Because it says identify the starting and ending vertices that can be used for the following graph to be traversable.
Right. For it to be traversable, that means if you go out here like this, right? Somehow, you don't have to end at the original point, right? But you travel across every single No.
This is really confusing.
what part is confusing?
Basically, it's trying to say that to be traversable, you have to have 0, 1, or 2, 0, 1, or 2 nodes.
0 or 2, actually. You can't have 1. I don't think
0
you can
or-
have 1.
Or
No.
2 nodes that have odd number of
Odd number of connections, basically, right? The degree is basically how many connections you have
Since there's only 2 here,
from that node.
and there's those 2 points become next time. So you can't have, like, does any of these kinds of questions, any of them, none of them are not correct?
Any of them?
So I think any of
Good. No, the question is saying identify the starting and ending vertices that can be used.
any of them would be correct.
Right? None of them is obviously not correct,
Like any of
right?
No,
Because it is traversable, so it has to be doable from some point.
Wait, so you have to like walk? No, you have to cross. No, get to each edge one time, exactly one time.
That means that's what traversable means.
I see like no way. If that no, I see no way that's possible.
How do you know that?
Because like, if you start at G, then you have three pathways. H, C, and D. If you start at D, then you can go to J, but then you go to H, and then there's no more pathway, and then you have to G. I'm not gonna.
So what if a graph has like one point that has 3 degrees?
That's not possible, is it?
What if I just drew one?
What
Um,
happens if you
Okay,
took
yeah,
like-
this question is really.
What happens if you took
How
away
many-
J and then connected H to what happens if you
put ABCD on those nodes.
Wait, so are these like?
So A has what? B has what?
Oh, wait.
Right, exactly, right?
Wait, yes, two.
So you can just try it, right? It's not none of them, right?
So
for
if
sure.
if
Because this is traversable. It has to be doable somehow.
so if the graph had that, so a graph must have 0 or 2 nodes that have an odd number of degrees.
If the graph meet that condition, right, then the graph is traversable.
I can see like 2 of the like from A, B, from question 4, I can see 2 nodes that have 3 degrees. A and E. A and E.
Yeah, that is true. Right. So let's try this. Let's try question number 4, right? Now you have determined that it is traversable, right? So let's say you start at A, right? You can do A, B, C,
E and then D.
A, D, E, right? See, what it means is that you have to go over every single edge. So you've gone this edge, this,
Oh, that's
This,
what you meant by
this.
edge.
this, right?
That's what you meant by edge. Oh my god.
Wh-
I thought edge was nodes
Okay.
for some reason. Okay, now I understand.
There are 2 problems with graph, right? There are two types of. One is that if you have to go through every node, that is the traveling salesperson's problem, right? That is, you have to go to each town, right? Every town is a node, right? You have to go to every town to sell your stuff. But you don't want to go back to the same town again, right? So that you can, do the shortest path thing, right? In order to go through all the towns. But the traversal problem is a different problem, right? Traversal means that you have to walk across every single edge.
One time?
But once, only once, right? You have to be able to do that, but only once.
Okay, so we were going back to like the famous bridge problem with how Julian solved it.
Mm-hmm.
Well, not this one, but like the bridge from last week. Well, like last
This
time.
one, right?
Yeah, this one. Then
Exactly.
we would try to
Okay. In here, you have 4 nodes, A, B, C, D, right? And every single one of them has odd degrees. Agreed?
Yeah.
A has 3, right?
Yeah, but didn't you say like
B is 3,
in order for
and
a
C
graph
is 5. D is 3, right?
So you said in order for a graph to be traversal, then 0 or
2.
2, exactly 2, but not like other numbers
Right.
greater than 2.
That means this is not traversable,
What
right?
is this about? What is this one?
Traversability means that you can walk all the edges, but exactly once, right? You can't repeat, you can't go backwards. And if you go from A to C on P, and that's done, right? You can't travel on that again,
Okay.
right?
So what it means by
These types of problems is basically, to understand how graphs work, right? Because a lot of times you need to be able to find out connections, right? So traversability means that you have a way to go through to go over all the edges. It's basically for some applications you have that type of need, right? You need to cross every single path, every single one of these connections in order to what's the right word? So let's say if you have if you are electricity, for example, right? Then you want to be able to cross every single path to power anything that is connected on that is put on that path, right? The electricity you have to go through the device in order to power something. Okay, I'm just making up an example here.
okay, so going back to the problem 5, not this one.
Okay, so the problem here is now we have determined that this graph is traversable, right? Because we have exactly two nodes.
Yeah, so
that
then it's
are-
traversable. Then it's a unit.
So you understand what this question is, right? Is asking you, right? First, you have to determine if it is traversable. But usually, I mean, because it is asking you to find the starting and ending vertices, right? So presumably it is traversed, but we can also, find out, right, where they are. And so the other thing you can do is, this is not none of them, right? Because it is traversable. So
Okay,
like I
so
said,
then,
you have to be able to do it somehow. Is it any of them?
no.
We can give it a try. Right? If you say F, E, D,
J, H, G, C, J.
it
Yeah.
probably won't work, right? Let's say let's try it.
Wait, so the starting and ending vertices are all, is the starting and ending vertices always the two nodes with odd degrees?
Right? That's probably not possible. So, and you could probably determine that these other nodes have the same kind of attributes, right? Or, if you start with H, for example, somehow is you've used one connection, right? And somehow you have to come back here in the end, right? You have to be able to, basically it is not possible. You can quickly determine that, right? But just by trying H, E, F, and C, these notes, right? Yep.
So like, it says identify the starting and ending vertices. So is the starting and ending starting and ending vertices always the two nodes with odd numbers? I mean odd degrees. Is that always true, or is it like sometimes?
I don't, that's a good question. Let's see the one that you drew, right? Yeah. It is, but this one has one, right? So these two nodes have odd number connected, right? This one has 3, this one has 1.
Wait. Oh yeah.
Now this one has 2. This one has 2. Right?
You try to figure this out at home.
This one has to know that one.
So
What are you doing?
So what I think is you can probably try the nodes that has the odd number of degrees, right? So if you try J,
Yeah, but then it says that a Euler's path is traversable if 0 or 2 vertices have an odd number. But then there's a 0. So then what do you do about the starting and ending vertices if there's 0?
in that case, you probably could start anywhere, right? Let's say if you have let's find one if we have one that is.
Let's try the square.
Yeah,
Yeah, a square works.
a
so-
square would work anywhere, right? If you have a square, you can just go any point. Right?
Yeah, but then the starting and ending vertices would be 1 point. Just 1 point.
Yeah, that's probably true. The other way to let's say if you have a square, let's see if we could find some way to draw. If I have this, let's see if we could use this program.
Whoa, what is that?
Did it start?
Inkscape. I think you have to wait. Wait, do you have a lot
Did
of
it
files
start
on
or
your
did
computer?
it not?
You have a lot of files on your computer?
Oh.
Oh, Gavin. Oh, Gavin.
Your document one escape.
What?
Okay, now they're,
Oh my God, there's 4. There's 4.
okay, it started.
Inkscape encountered an internal error and will close now. Probably because you opened a lot of files.
Probably. Could be. Okay. It closed everything. Let's see, try again.
No, click it one time and then wait. Escape. Whoa! That was escape. This looks like some sort of.
No. Okay. How do I just create a new document? Let's see. Thing is a bit too small.
Why is there just like a white? Is that a canvas? Piece of paper? Yeah, is that a canvas?
Please don't do that. Okay, so
Are we making our own graph?
yeah. So let's say if we have,
Wait, are you sharing your whole screen?
I don't know how to use this.
Are you sharing your whole screen?
Yeah.
Are you? Okay.
So one node.
And then copy and paste.
Two nodes.
Nodes. How many nodes are we gonna add? 5. Okay.
Oh wait.
Oh my God. That's a big node. That's a big boy node. That's good one. That's gonna take myself a year or so. Yeah, but like they have to eat
So,
and drink. Yeah, but like
So if we have these 4 nodes, right?
we have 4 nodes now.
We have these 4 nodes.
Oh, you mean 5.
Oh, we got 5.
Okay, so are we gonna use like some sort of
Okay. So if you have 4 nodes, right? So we connect them. Oh, let's see. I think the.
there's like a
Hold on, let me just quit this.
there's
I'm
like a drive.
not liking this very much.
Why
So
did you close it up?
if I go here, right? If I go here,
I
oh.
can make you one.
let's just create a
Okay, I made you 4 nodes.
so you can do a Google drawing here. It's
Oh,
much
Google
easier,
Drawing,
I think.
Well, I'm making one for you then.
Oh,
Okay, so
not creating a map.
teacher.
Uh-huh.
Yes, I'm calling you teacher. No, I made this. So like,
Okay. this should be easier. So if we have, let's create 4 nodes, right?
4 nodes, okay.
Right, this is
The 4
A,
nodes,
for
A,
example,
B, C.
right? And we can copy this node.
No, it was.
All right, so
Basketball Academy.
right, so we have 4 nodes. Let's rename them. This is B and C and D, right? And so now we can connect them.
So you can connect them to a line.
Oh, come on. So if we connect them, and here we have how many number of degrees? This one would not be traversable, right?
Yeah,
Because every one of B, C, D has 1 and A has 3, right? So we have
but
a lot more.
so then
But if we connect this, we add a connection, then it becomes traversable, right?
Wait, A has 3, D has 1. Yeah, okay, yeah.
Right? It is traversable. And also if we connect this here, it is still traversable. Right? Because you got A3, C3, right? And in this case, this kind of case, you can see that if you go from A, B, C, A, B, C, right? That's one way of traversing the graph, right? So if you start with the nodes with odd number of connections, it's very likely that you can do the traversal, right? And now if we add a node in the middle, oops, don't mean to do that. Okay, this is E, right? If we do this, and this connects to, oops, to that. This connects here. And create another edge. Just do this. Here's another edge to connect here to here. This is still traversable, right?
ES2, DS2, AS3, CS3. Yeah, it's still true.
Right. And so now if we add one connection, it would break, right?
One connection?
It would not be traversable anymore. If we add one connection from, let's say,
yeah, because DS3
to anything,
then
right?
DS.
This is not traversable anymore. And if we keep adding it,
No, that won't work.
that would still not work. But if we add another connection from let's say from here. Come on. What's going on? Didn't mean to do that. Right, if we added that connection, added that connection. Okay, we'll just make do. Yes. So if we add that connection, it becomes traversable, right?
Oh, wow.
And still, or we can just let's see.
Wait, can
We
grab
can move
her?
this closer here, so to make that a little more readable, right? And now you have two of these nodes, A and C again, that are that have odd number of degrees, right? So again, let's try this. C, if we go from A, B, C, right? That would work, right? If we start with one of the nodes that has odd number of degrees, right? Let's try C.
C
I believe
has,
it would be the same, right? C,
A has 3, B has 3. Wait, B has 3. I mean, no, B has
let's see.
4. C has 3, B has 4, E has 4. Okay, yeah, it's traversable.
It would be the same as this is actually symmetrical, right? It would be starting with C or A is the same, right? So if we go A, B, E, A, B, E, C, and I think that's it, right? Right. So we can, start with A and finish at C, right? So you can just try this a couple of times, then you would have the solution, right? In this problem, number 5, obviously, if we start with G, J and G, G and J, so the answer is A, is obviously doable, right? And then we can try D and G. Right?
Yeah, but then D has 4.
So, right, you can try starting with D, right? So D, for example,
H, G, C, J. No,
right?
no, it did 2 times. So
It is, it is not possible because let's see.
wait, I think
D,
it's
E,
possible.
F, E, right? We can finish this part first,
Yeah, and then go to
and then
J,
go over here.
C, G. Wait, no, it's not doable.
It's not doable, right?
Even
Because when you got here, somehow you have to be able to, go to from this point, go to another one, and then not repeating any right edge. That becomes not possible, right? J and D probably the same, right? So that gives us the answer GJ. Well, any of them is basically, if you failed one, then that's not true, right? D is not true, right? Because it's obviously not any one, because if you try C, right? C, J, H.
Wait, so if
And
you,
now
no,
you're
if
gonna
you,
repeat. Right?
if you failed an answer, then it's not any of them. And if you completed an answer, then it's none of them. No, then it's not none of them.
Right. Well, it cannot be none of them because it is traversable. We have determined that. It has to be able, you have to be able to do it somehow. We just don't know yet how, right? That's so we can eliminate that need, right? And then by doing any of these points, right, that if it fails, then it's not any of them, right? It cannot be, because if you try F, for example, F, E, E, and then you have to go,
J, C, J, H, C. Then you miss, D,
you either
G,
miss
and F.
some of them or you have to repeat some of them, right?
Yeah.
So that means it's not any of them. So now you can just try G, J. If that is good, then obviously that would be the answer, right? You can't have two answers in this context. All right. So we finished this. Let me pick another one that we can work on. Right. So these are the answers, solutions. Let's do another one here. Okay, so remember, right, the traversability is one problem that you will definitely see. Okay. So the first one, given the following description, list all the edges represented using the first letter of each person's name. Do not include any duplicates. Well, so Amy, A, D, E, B, C, right? So A, B, C, D, E, and all that.
Amy shakes hands with, Amy shakes hands with Dave and Ellie. Dave and Ellie. Dave and Ellie.
Oh, here.
And,
Let's do this.
what time is it?
We have another half hour. So let me do this. And yeah, let's do a short break. This is the problem, right?
Wait,
So-
is this finale or is it like? No, this is contest 4.
This is the one that we're working on, right? Did we work on this one
Yeah,
before?
wait.
So we
No, I
have
think we did. No, I
A,
don't-
B, C, D, E. A, B, C, D, E right here. Okay. So A is Amy, B is Ben, and Carol, and Dave, and Eli. Right? If we delete all the edges for now.
Ben shakes hands with Ellie, Carl, and Dave.
Right? It's probably easier to draw on a paper.
Yeah, I'm doing it. Okay, we're gonna do this question and then we're gonna do right. Yeah. Dave shakes hands with Amy, Ben, and Carl. Dave. shakes
So
hands with
Dave,
Ben and Carl. Amy, Ben, and Carl.
oh, color.
Amy, Ben,
Okay. Dave,
and then
oh,
Carol
it's
shakes-
Amy, right? Amy, with Dave
Okay, I've made the.
and Amy with Eli, right?
Okay, I think.
Let's see. Oh, we don't have any, yeah, right. We don't have any directional graphs. So, and Eli shake hands with Amy. That's already there. And then Eli with Ben. Right? And Ben with Eli and Carol. And Dave. Right? And Dave shake hands with Amy,
Dave shakes hands with
Amy,
Ben,
Ben,
and Colin.
and Carol.
Okay, so there's. I should have brought one.
And Carol shake
Yeah.
hands with Ben and Dave. That's
Yeah,
it.
so you don't
Right?
need-
So this is the graph.
Yeah.
And then,
Yeah,
like,
but what watching it?
Yeah, no, it's fine.
so that's it. Or we can make it, move it up a little bit.
Okay.
So that's the graph. Right. So now it wants us to list all the edges. So what do we have? AD, AE, BC, BD, BE, right? And then CD. Well, BD is already there. BD, BC, BE, right? And with C and then CE, CD, because BC is already there, right? So let's see what they're. Okay, let's do a take a break and then
Okay. Why does it seem like it's about to sunset? But it seems like it's never sunset.
so let's do it again. So with a complete graph, right? It's asking us to make this a complete graph. For the given graph, identify the set of edges needed for this graph to be a complete graph. Complete graph meaning that each node has to be directly connected to all other nodes, right? Individually. So we got AB, but we don't have AC, so we identified AC, right? So we need, let's see what we need here. We need AC, right? And then do we have AD? We have AD. Do we have AE? We have AE, right? So we're good there. And now we start with B, right? Do we have BC? Yes.
Yeah.
Do we have BD? No. So we add BD. Do we have BE? Yes.
Yeah.
Now we go to C, right? Do we have
That's not
CD?
BA.
Huh?
We also have BA.
Right. AB and that's already counted, right? We have CD, right? But we don't have CE, right? And now we're down to D, right? We have D. D is basically E, right? We don't have DE, so we need DE.
And then E is all connected.
Right. Once we got to E, is already it would be all connected. So those are the four edges that we need, right, for this to be a complete graph, right? So these concepts you need to understand, right? We have the these concepts are all there. We did go through all of them, right? So we are all at the elementary level. We're dealing with undirected graphs. So there's no direction, meaning that if we have A, B connected, then B is connected to A, right? That's what that means. So complete graph, this is the concept, right? An edge exists from every vertex to each of the other vertices in the graph, right? So from each node, you have to be able to go to other nodes. There is an edge to other nodes, all other nodes. So that's complete graph. So all these concepts are there. You just need to understand them, right? Cycle, we did go through that. So this is the traveling salesman's problem, right? Meaning that you have to be able to go to all nodes, right? That's it. So if you have a cycle that goes through all the nodes, you're there. Then this is the traversability problem, right? Traversable or not. So just these number of concepts in this slide, right? You got to go home and basically just remember all that. So the next, where's the next? Okay, the next problem, number 3. So if you're delivering pizza from location Q to all other places and return to Q when you're done, how many different routes could you take?
Oh, that's good.
Right. So basically, it's
How many cycles?
starting with Q. Right. Exactly. Finding the number of cycles. Right. So what you do is you again start with the with order. Right. So if you go Q, P, R, P, S, Q. Right. You can. That's one. Right. And then you do Q, R, P, S, T, Q. That's another one, right? And you can do Q, S, P, R, T, Q. That's another one.
Q, P.
Right?
No.
And then
R,
you Q, T, S, or Q, T, R, P, S. That's one. And also Q, T, S, P, R, Q.
If you were to
another one.
start at
So-
T, you can make like a star like T, Q, S, P, R, T. If you were to start at T.
No, it says you have
Yeah,
to
but
start
like
with
if
Q,
you
right?
were to start at T, you could make a star.
I see what you're saying. Yeah. And you can do this. You can use this Q as a point of the star as well, right? So you can do this. It's also. So basically just go through all those cycles and how many, right? So that is that problem. Now this one, WXYZ, in the undirected graph below, how many cycles are there? Remember, the cycles must include at least 3 vertices in undirected graph, and it's different cycle if it goes the opposite way. So start with W, right? W, X, Y, W. That's one. Right?
W. Why is it called W? It should be double.
W, X, Y, W, right? W, X, Z, Y, W. That's another one.
W, Y, Z, X, W.
W, Y, Z, X, W. Yeah, that's another one.
Yeah, I think that's it for some reason.
No, wait, did we do WYX? W?
Yeah, I think that's pretty much it. Because if you start from a different point, if you start with Y, for example, and you go through the same cycle, then it's the same cycle, right? So W, X, Y, W, X, Y, W, and Y, W, X, Y, that's the same cycle, right? So just remember that when you do this type of problem, right? So, yeah, the way I would suggest that you do is basically you start with, use the alphabetic order, just so that you remember things, right? And if you write them down, you can also, if you start somehow differently, you can also you can sort them, right? Write those paths down and then sort them, and so that you don't repeat anything. Last problem, identify the starting and ending vertices that must be used in order to traverse the following paragraph, following graph. If it's not possible, write none. So first we determine, is it possible?
We have to find 0 or 2 vertices. I'm pretty sure it can't be 0 since C has 3.
Yep.
So
C
has
and
3.
G, right?
Actually, yeah. Wait, hold on.
C and G are the ones.
Yeah, I'm just checking if any else has like an odd. Yeah, I think it's traversable.
Right. So yeah, C and G, they have 3, right?
So then CG.
And all the other ones like D and E, they have 2, and all the other ones have 4. Right. So it is traversable. So again, like we talked about earlier, right? If we start with the one that has a odd number of connections, we can pretty much traverse the whole graph, right? So if we start with C, right, starting and ending C and G, I think that's pretty much it, right? You can just basically, you can try it once, right? Starting from C, see if you can finish it in G, right? And once we know this, it is probably, once you see this problem, you pretty much know what to do with it, right? It's C and G. Right? Okay, great. So, I will put this document, this one has a list of all the, previous stuff that are already there. If you have time, go through them. If not, then yeah. We have one more. And yeah, we have one more. Yeah, then it's done. After the next one, the new school year starts also. Right? So initially this was the last one, but we skipped it last week, so we have one more. All right. Have a nice weekend.
Sometimes it doesn't work.
Thank you. Bye.
Bye-bye.